So we've deployed that Acme 2.jar and it's failed. You can scroll up and see why. It's failed because we're missing this module requirement print. Again, that was due to the statement that Acme.jar depend upon a print module. So now if we deploy the print.jar, so we see that the Alesh and Scott service have started and that the code path to the PrettyPrint class is this deploy print.jar. Okay? Again, if we look at the Acme 2 jar, I think it's called Acme. So we actually do have a PrettyPrint.class in that jar. So we have excluded what typically you would find in a normal, or in fact even JBoss 4. All the jars would have, all the classes would have been available from that Acme.jar deployment. And here we've excluded that, and in fact are importing it from an external one. Right now, if we now we can deploy the foo bar MC beam deployment. And that starts up fine, but now if we remove the Acme jar, basically are removing its source of its injected services. So we see the Scott and Alesh services stop, but prior to that, the foo bar service was destroyed. Now if I touch that foo deployment, try and force it to be redeployed, it's going to fail. Because its dependencies on those two services packages are unsatisfied. So we can't find an Acme Alesh in the version range 1 to 2 inclusive, or an Acme Scott in the version range 3 to 4 non-inclusive, right? But if I simply redeploy the Acme jar again, then we see that we have restarted the Scott and Alesh services, and foobar was therefore had its dependency satisfied, it's been created, those services injected, and then the service started. So that's the basic gist of how how we've extended our old UCL class loading model basically to be a superset of an OSCI bundle or Java module type of system in terms of describing imports and exports between deployments, as well as integrating those dependencies tightly into the life cycles of the services that are referencing those classes.
I have a different demo to show. Basically, like I said, the class loader itself is driven by the policy. By default, there's a VFS policy. What I'm going to show is I'm going to use my own mock policy, which will do sort of a bit of a hacky thing, but just to see what it does, how easy it is to change the policy, or meaning that you can change the behavior of the whole deployment. Let me just switch. So the idea is to have like again Alesh and Scott services. And there's the foobar service, which just prints out the Alesh's activity and Scott's activity. And in version 1, I'm gonna have all the fun. We're gonna have fun. Like Scott is skiing, play basketball. And in version 2, I don't have any free time, and Scott needs to shovel snow. But like I said, the foobar service itself, I'm just gonna print out, and now I'm gonna declare a policy which does the split between the jar. So the foo jar is gonna have it's gonna take AdsMe Alashes version 1 and Scott's AdsMe version 2. And to change the policy, I just needed to change. This is the Bootstrap. It's a pretty similar Bootstrap XML from the JBoss AS. And all I needed to do was just comment out the default one, BFS class loading dependency describe deployer with my own class loading describe deployer, in which I create a class loader policy module, which basically creates the policy. And like I said, what it's going to do is it's going to understand how to split the foo's matching of the different versions of the AdsMe. And it's going to run demo. All of this is available under MC's demos project, which I try to fill in with different pieces of MC, like IOC, component mixture, class loading VFS, and so on. And it's all downloadable from SVN. And like you can see, I can stop now. But Alash's free time activity is play basketball, have a beer, and Scott's activity is shovel snow. So it took the foobar service took Scott from version 2 and it took Alash from version 1 just by creating a simple policy. I didn't have to change class load at all, didn't have to download anything, just did a policy and it was all there. Okay, back to the presentation. Okay, moving on to the different flavors of OSGI that we currently support. The first one is, we call it embedded in AS in application server, meaning that an existing OSGI framework, Felix, Hopperfish, Equinox, can just take it and put it in the AS as a service. What we added on top of it is a framework abstraction, just to be able to talk to different existing OSGI frameworks. The OSGI itself, with the spec 4.2, is going to have proper framework abstraction, so you don't need to use your own, like in the case we did. But since we want to support previous specs, we need to implement that on our own. The other thing that you just add is additional OSGI deployers, meaning they're able to delegate some of the work to the existing OSGI framework. For example, they understand how to recognize bundle as the structure, and they're able to delegate the work to the class loader deployer, just to wrap up the bundle as the class loader, not to use the stuff that we saw before with policy and base class loader and so on, but just take the existing OSGI framework, take the bundle, and export it as a class loader, and assign it to the deployment unit. But the problem with this approach is you have limited access to some external class loader communication, since OSGI is not actually the kernel, it's just a service. And to be able to access, it means that other pieces that you deploy in as a bundle are not able to easily see some of the things from the AS application service bootstrap class path. There's a picture of how actually the schema looks like. The next approach is, we call it runtime.